So on page 54, you're titling it Measures of Dispersion and Stem and Leaf Plots. Okay, this is the last little bit of this particular unit.
Students at this time.
Okay. So this is the last little bit for this particular unit with descriptive statistics. We're going to talk about measures of dispersion and stem and leaf plots just very briefly. Measures of dispersion. Smart notes. Smart notes. This is actually going to go on your line, on your lines. Measures of dispersion basically tells you how spread out the data is. Okay? It tells you how spread out the data is. Measures of central tendency actually tell you about the data, like what is your mean, what is your mode, what is your mean. It actually talks about the data, but that's measures of central tendency. But measures of dispersion tells you how spread out your data is. Okay? Now the simplest measure of dispersion is the range. We've already talked about range at the very beginning when we were talking about frequency distribution tables. You find your range by doing what? Huh? The highest value minus the lowest value. The max minus the min. Okay? So that second bullet, you don't have to write down because you know that we talked about that before. Another type of dispersion is your interquartile range because it talks about the spread of the middle 50%. And this formula for interquartile range is Q3 minus Q1, which we talked about the last class. Okay? Now, one that we haven't talked about yet that is new is standard deviation. Standard deviation gives you an idea of how the data values are related to the mean. It basically gives you an idea, again, of how the data values are related to the mean. Now, there is a by-hand way to find the standard deviation, but that's for our statistical applications unit, which we're going to do after we finish up this unit, okay? But you do need to know how to find it in your calculator, and that's what we're about to do now, okay? So go ahead, if you don't have a calculator, pull it out, and we're going to look at our very first example, which says the mean of these numbers is 33, which should be the first example in this little white booklet foldable, okay? We're going to find the value of x, we're going to calculate the standard deviation, we're going to find the range, and we're going to find the interquartile range, okay? Now, to find the value of x, if the mean of the numbers is 33, we did that back when we talked about measures of central tendency. How do we find the value of x? What do we need to do? You said 33 is equal to what? Just in general, what's it gonna be? All the numbers, including x. So what are we gonna do to all those numbers? We're gonna add them together, and then we're going to divide them by 7 because there's 7 numbers here, right? So when I add up 16 plus 41 plus 24 plus 62 plus 18 plus 25, you get 186 confirmation?
Yeah.
So it's 186 plus x, okay? Now remember you have that whole white space, like this is for this particular problem. How do we solve for x? Multiply by 7. What's 33 times 7? 231. So I have 231 equals 186 plus x. How do I solve for x? 45 for x? 45. So the value of x is 45. Now questions on that. That was measures of central tendency. Now, to find the standard deviation, we needed to know what that value was because it is a part of our data. So to find our standard deviation, we're going to go to our calculator, and we need to type in our data. I talked about this last class. Where do you go to type in your data?
Stat.
You go to stat. And then once you go to stat, you need to go where? To edit. So I'm going to go to stat. I'm going to go to edit, and I'm going to type in my data. Now, I only have one set of data. So I'm going to type all this data into one column. Which column? L1. So this L2, I still have data in from when we did it the other day. How do I get rid of my data?
You go up, highlight L2.
I need to hit clear and then enter, not delete. I also don't need this data from the other day either, so I'm going to do the exact same thing. Go up to L1, hit clear, then hit enter. And now I'm going to type in my data, 1641. Continue to type in your data. It does not need to be in order. The calculator will do all the ordering for us. So we just type in exactly how it's given to us. All right. Now we have to go and pull that information like we did the other day. So where do we go? We go with stat. Go over to calc. 1 bar stats. Now, if your calculator looks like mine, did we have a frequency list? No, we didn't have anything in L2. So if yours looks like mine, we're going to need to clear out our frequency list. If your calculator does not look like mine, that's when you do second 1 to get L1 onto your screen. I only have one list, just that one. So second 1, if you need to put in L1, and when I go to calculate, you see how that first number is 33? Yes. Remember I talked about this the other day. The X with the bar is the calculating notation for mean.
Mine is 34.
So just to confirm, the mean is 33. Like it told us in the question, it is that very first entry right here. But we are looking for the standard deviation. The standard deviation is this symbol right here. It looks like an O with the extra tail at the top. This is the calculator notation for that.
Wait, does that represent minimum?
No, this represents standard deviation.
You get the mean. Oh, no. You get the mean, you go down.
And yes, you do 3 significant figures. So what's my standard deviation?
15.6.
15.6. So again, this symbol with the extra tail means standard deviation.
Did we do something else with standard deviation?
Okay,
Maybe not in this class, no. Standard deviation basically tells you how your data relates to your mean. Okay? So right now I'm teaching you how to find it. When we get to statistical applications, we're going to talk more in depth about standard deviation. Just right now you just need to know how to find it. But again, it basically tells you how your data relates to your mean. Okay? And we'll talk more about that once we get into that next unit. The range. How do we find the range again? Highest minus lowest. Now, just to confirm, wasn't 16 our lowest value?
Yes.
Wasn't 62 our lowest value?
highest.
Highest value?
Yes.
So there we go. So 62 minus 16. Just in case, let's say we had a little bit more data than just 7 pieces. If you know, sometimes you might miss where the smallest value is. You can always use your calculator to confirm that. What's 62 minus 16?
46.
46. So that's our range. And since we did use our calculator for this, interquartile range was Q3 and Q1? 18. So our interquartile range is going to be 45 minus 18, which is 27. There's all of our information. Now, yes, when we were doing box and whisker, we could have so used our calculator to figure out our Q1, our Q3, and our median. But I want to make sure you guys know how to do it by hand as well. But you can use your calculator to double check your answers if you're running out of time. Awesome. Okay?
Oh, so you do it on paper to get like
Mm-hmm. Questions? All right. Let's look at the next example. So when you flip up, it should be this one, talking about the 80 plants. Okay. Their heights correct to the nearest centimeter are recorded in that table. The table's right below it, correct?
Yep.
Perfect. I want you guys to, actually, let me look at the last example. Okay. I want you to find the value of M. How do you find the value of M? You can either add them all up and then subtract from 80, or you could just do 80 minus all those values. It's the same thing. Like I said, little work. The value of M is what? 9. All those should add to be 80. So now that I know that piece of information, let's find our mean. We know how to do it by hand, correct?
Yes.
That was measures of central tendency. We did that for frequency tables. Okay? Now's the time to practice making sure we can do it in our calculator. So we're going to go in. I'm going to go back to what button? Stat. I'm going to go to, what's going to go into L1? My heights. What's going to go into L2?
Frequency.
Very good. Get to typing. So we have our data in there. Now we have to pull out all of our information. Where do I go? Stat. Calc.
2 bars.
There's still one variable here. What's that variable that we're dealing with? The x values, which are the what? The height. The frequency just tells you how often these heights show up. So it's still just one variable that we're dealing with here. Don't worry about 2 variable statistics, just one. One variable here is the heights. So we go here. If your calculator looks like mine, this time, do we have a frequency list? So if your calculator looks like mine, you're going to go down and you got to type in L2. Second 2. If your calculator just pops up 1 bar stats, how do you get L1 and L2? Second 1, then comma, second 2. And when you press that series of buttons, you should get L1, comma, L2. You need your L2. If you don't have it, the calculator is only going to find all the information for your heights, literally those 7 pieces of data, not the fact that there's 80 of them actually. So that L2 lets the calculator know that, oh, these numbers show up this many times, so I really have 80 pieces of data. Does that make sense? So when we click enter or calculate, depending on what version calculator you have, raise your hand if your data does not look like mine. So, what is my mean? So 12.7, 3 significant figures. What's my standard deviation? 1.49. Remember, it's the symbol with the O with the extra tail, so we got to round to 3 significant figures. 1.49, because the 9 will make you round up to 8. Now we have to find our interquartile range. I'm going to have to scroll down, right? So scroll down. It's going to be 14 minus 12, which is 2. Avoid skipping the step of actually writing down 14 and writing down 12. Do not skip that step. Make sure you write that step down. Questions? The last one you're going to do on your own. You're just finding the mean and standard deviation for this one. Yes, use your calculator. Whenever you have a group frequency table and you're asked to find the mean or the standard deviation, you need to use the what here. You got to use your midpoints to get an approximation of your mean. Because remember, because it's the range, we don't know exactly the data. So we cannot find it specifically. What's the midpoint of the first class?
17.5.
The second? The third? And I'm recognizing the pattern. It's the same as the width of each class. I'm going up by 5, so the next one should be 32.5, 37.5.
Yep.
Ooh, not 30. 42.5 and
47.5.
so I'm going to use that in my L1 because I have a grouped frequency table. Group frequency tables, I use my midpoints, not my upper boundaries. Upper boundaries are used to graph. Midpoints are used to find information. Easy to remember?
Yes.
Okay. Oops, I messed up. If I mess up, Don't try to sit there and delete what you type. Just type over it. Okay? 47.5. And then in L2, I'm going to type in all of my, can y'all read them out since my calculator covers it? What's the first one?
3, 7, 10, 11, 12, 15. That's 5. See, I got this up too because I thought it was 15.
That is a 5.
What? I thought it was 15.
That's not the 5. Okay. So I mess up, just overwrite it. Then I'm going to go back to stat, over to, and down to, I only have one variable, but I do have a frequency list, L1, L2. The only time that that's not going to be there is when you reset your calculator. For those whose calculator looks like mine, that's the only time you actually have to retype that in. So once you have L1, L2 there, it'll stay there until you delete it. For those who, again, just one bar stats, you do need L1, comma, L2 there. Did you have that? So that means when I hit calculate, everyone's, a lot of stuff going on there. Everyone's stuff should look like mine.
Yes.
So what's my mean?
32. Around 30.
And my standard deviation?
7.57.
7.57. So my mean, now, this is important to realize. The X with the bar is the calculator notation. There have been many times that I've said to this point now that you do not need to use calculator notation when you write it down. The symbol for mean, internationally, across the board, is the mu symbol, the Greek letter mu. It is basically an M with a elongated tail in the front and like a little kick up at the end.
For micrometer. Yeah.
Okay? That means mean. That's the symbol for mean. So when you write this down, that's the symbol you should use, not the X with the bar. Does everybody understand that? So 32.
So which is the same change?
Standard deviation actually is the exact same. It is still the O with the extra tail. And you said it was 7.57?
Yes.
Boom.
You put the X there beside it.
Because that's just to let you know. When you do two variable statistics, it will show an X and then a Y because you'll have two variables.
Okay.
So that's why it says X automatically. Question. At the bottom of that, at the bottom of the page, that's where you're gonna put those yellow stem and leaf plot examples. This is just another way to represent your data. It basically splits your data into what's known as a stem, which is the first digit, and a leaf, which is the back end.
This is all on page 50.
This goes all on page 54. So these examples, I know, do not look like the examples that you have, but the one thing that they all have in common is they give you a key to let you know exactly how this data works.
How?
Okay? So the stems represent one, the leaves represent the back end, and when you put it together, it actually gets you your number. So, in this case over here, this and this would actually represent what? Look at the key.
Percentage.
It would represent percentage. So I circled the 2 and I circled the 1. That would represent what? It would represent 21%. This and this represents what? 51%. Look at this example over here. This and this, look at the key.
115%.
This will represent 115. The key will tell you what the number is, okay? On your yellow foldable, the first one, the one that says stem and leaf, okay? The one that says stem and leaf. You see the key down at the bottom where it says 2/3 equals 23? That's your key. Again, it's just another way to represent your data, okay? Look at the one that says volumes of liquids in milliliters. This one looks just like the second one that's on our screen right now. It gives you a key, except this time the bar actually represents a decimal. So you would have 5.7 and 5.8 instead. The last example you have is known as a double stem and leaf plot, kind of like what I have over here, where you have two pieces of information, boys and girls. I don't know, maybe this represents, I don't know, something about boys and girls. But, you know, this right here, like say you have a 9, oh actually let me not use 9 because that's not. So if this was your key, this was 6, and this was 5. This could mean 105 or 106, depending on what the key tells you. Look at the one that you have. The one that talks about shoe sizes for 4th graders and 5th graders. The key down at the bottom tells you 3.0 and 3.5. So that's exactly how you use it. One would stand for the 4th graders, one would stand for the 5th graders. But the main thing is you got to use the key. But you can still do medians, Q1s, Q3s using the data. Okay? If I go back to this example, because it is one of our smaller examples here. This one right here. Each one of these basically represents a piece of data. So 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this is 16 pieces of data summarized into a stem and leaf plot. So 16 would be your end for you to perform your median and everything too. Okay? Look at that very first one, the one that looks like this. I can't find mine for whatever reason. I cut them out, but I can't find it. This one, how many pieces of data is this particular example?
4. No.
4 is just for the first one. There's 13. You would add them all up. So you have 4 that are in the 10s, 4 that are in the 20s, or 2.0, whatever, 2 in the 30s, and then 4 in the 40s, or 3 in the 40s. Questions on stem and leaf? How to look at it? Yes?
So one of our examples from two sides of the 4th graders, like on the left side is like 0.5, 0.5, and then 2 in the middle. So like you add the 0.5 together? Or?
The one that's in the middle is representing this, the base, the stem. This is the stem in a double stem and leaf plot. Okay? So when it gave you that key that said 0, 3, 5, this one on the left represented the 4th graders. This one on the right represented the 5th graders.
I get that, but like there's 2 decimals like on the left side. Like it's 0.5, 0.5.
Yeah, so it's 2.5.
So yeah,
3.0.
it'd be 2.5, 2.5, 3.0,
So
3.0.
2.5 twice.
Yes.
Okay.
So that means there's 2 people that had a 2.5 of shoe size.
That's what I was asking.
Yes.